Now the question arises, what happens when we dissolve the ionic compound in a solvent? So when an ionic compound is dissolved in the solvent, the ions leave their ordered position on the crystal lattice and becomes free in the solution. So here we can see that AB is the solid, and when it is dissolved in some solvent, then it dissociates to give its ions in the gaseous state first. But because a solvent is surrounding our solute, therefore these ions, they get solvated, and in case water is the solvent, then they get hydrated. So you can see that now these ions are not present in the gaseous state, but they are surrounded by the water molecules here, and it is represented by AQ. Thus we can see that the overall heat of the solution is equals to the lattice enthalpy of the solute and the hydration enthalpy. Actually, the hydration enthalpy is the amount of energy released when the ions get hydrated. So we can say that heat of solution is equals to the sum of enthalpy of lattice energy, or lattice energy simply, and the hydration energy. Now there are some important notes. For most of the ionic compounds, the enthalpy of solution is always positive, and the dissolution process of such ionic compounds is endothermic. Solubility of such compounds always increases in water with the rise in temperature. Now, many fluorides are less soluble than their corresponding chlorides. The reason behind is that because of the high hydration enthalpy and lattice energy of the fluorides than the chlorides, and the difference between the lattice enthalpy and hydration enthalpy is always greater for the chlorides than the chlorides. Thus, the solubility of fluorides is always less. Now, enthalpy of solution depends upon the amount of the solvent also. Now, coming to the enthalpy of dilution, it is defined as the difference in the enthalpy of solutions at different concentrations. Just now we have mentioned that the enthalpy of solution depends upon the amount of the solvent. So we can see, taking the example of HCl, when this HCl gas is dissolved in different amount of water, then the enthalpy of solution is also different. As we can see in the first equation, here 1 mole of HCl gas is dissolved in 10 moles of HCl, and the enthalpy of solution is minus 69.01 kilojoules per mole of HCl. When we dissolve the same 1 mole of HCl gas in 25 moles of water, then the enthalpy of solution is minus 72.03 kilojoules per mole. When we make solution of 1 mole of HCl gas in 40 moles of water, then the solution enthalpy of the solution is minus 72.79 kilojoules per mole, whereas the enthalpy of solution at infinite dilution is minus 74.85 kilojoules per mole for HCl gas. Now, if we take our second solution, that is where the HCl is dissolved in 25 moles of water, and to this we add 15 moles of water. That means we dilute our solution. Then we will find that some energy is released during the process, and the amount of energy released during this process will be equal to the difference of the energies of the enthalpies of the solution. So here the enthalpy of solution, which is obtained by diluting a 25 mole water solution to 40 moles of water solution, then the amount of dilution or the enthalpy of dilution will be minus 0.76 kilojoules mole inverse. The enthalpy of dilution depends on two factors, and these are the original concentration of the solution and the amount of the solvent added.